To our speaker today, I'm very pleased to be introducing Dr. John Moore, who is a professor in the Department of Biological Sciences and the School of Resource and Environmental Management at Simon Fraser University, and holds the Lieber Era Research Chair of Coastal Science and Management. He leads the Salmon Watersheds Lab, which focuses on freshwater biodiversity, watersheds, and global change, with particular focus on BC's rivers and their salmon. They work closely with a diverse array of collaborators and partner organizations and work hard to try to link science to positive watershed change. And with that, I'd like to welcome John and join you all in doing so as well.
Well, I just want to say thanks for the opportunity to be here today. It's fun to be here in person. I feel like I haven't done this very much lately, so I get that sort of adrenaline again, and I'm excited to share this room with you all. Today, what I'm hoping to do is just showcase some of the work that my group has been doing, and I hope that it also might resonate for you in terms of thinking about your systems and how your work feeds into these complicated ecological systems in which we live. Okay, so I want to take us underwater, and if we go swimming in the fall, we might be lucky to see this. The bubbles might clear, and then around us are salmon. They're on their journey upstream to the places where they are born, connecting the oceans to fresh water and back again. And in general, I think the challenge that our research program and many other people are really trying to think through is how do we, as people who are causing both climate change and direct impacts on these salmon systems, how do we manage these systems in this time of change, in this time of these dual impacts of climate change and of direct pressures on these systems? These systems that contain important species like salmon, but then also contain us as people, as parts of these systems, as part of these working watersheds. So if we step back, the schemata looks something like this, a cartoon of humanity causing climate change, which affects ecosystems, but then we also have these direct impacts of these ecosystems that we are a part of. And so I hate to say this, but if you don't like salmon, just whenever I say salmon, imagine your favorite species, okay? And I think maybe the messages, maybe the themes will resonate for those species. So maybe, I don't know, maybe it's caribou, probably not in this audience, I suppose, or something else. But I think hopefully some of these ideas will cross across the salmon sphere that I think a lot about. So in terms of the salmon life cycle, these salmon are born in fresh waters. They rear there for up to a couple months or years. And then they migrate downstream through estuaries to the ocean, where again, they'll spend up to 5 years there before returning home. So across this life cycle, you can envision there could be a suite of pressures on them, different sets of challenges, different sorts of human activities that can harm them. And as we think about these systems, these vast connected watersheds, I think it's really important that we remember that these systems have been stewarded by people for millennia. And we also live here, they're working watersheds. And so I think this sort of cultural fabric of indigenous peoples in particular is a real sort of key thread that we need to hold as we work in these landscapes. And what happens to salmon isn't just what happens to the species, but it's a real sort of potential harm to the people that rely on those species. It's a matter of environmental justice, it's environmental and social harm. So this overarching question that I'll be touching on today a little bit is how can we steward these salmon systems, these complicated watersheds that we're a part of, that have flows of water from glaciers to the ocean, and that fish are migrating through and then back again. How can we steward them given climate change and multiple stressors? And I feel really fortunate to lead the Salmon Watersheds Lab. We're a big team of about 20 folks at SFU. And we try to sort of really intertwine three main approaches. We are increasingly using sort of big data approaches, a combination of remote sensing, and then also compiling the vast data on salmon. Lots of people have studied salmon, and it's, I think, timely to start bringing these data together. So that's one of our pillars. We also try to sort of pair that 10,000-foot view with real sort of wet boot science, getting muddy, exposing ourselves to the complex realities of how these systems work, working shoulder to shoulder with the true experts that live close to these systems. And then increasingly, we also try to connect and catalyze. A lot of people think about salmon, lots of stakeholders, lots of right holders. And so we're trying to sort of play a part in uplifting the work of many other people. Our team has a lot of different collaborators and support. I don't think this is quite up to date, so I apologize if I'm missing somebody, but it's really amazing to get a chance to work in this diverse landscape. And towards this aim, we've sort of thought about our vision as working towards thriving watersheds for people and salmon. And I think if we can get that right, we can get a lot right. So to get there, there's sort of two things that need to get intertwined, right? One is hopefully there's a scientific basis for this. So we're trying to think about these fundamental questions about how do these systems work? How are they changing? And then at the same time, pairing that with thinking about, well, what to do about it? You know, how do we action this information? What to do to improve or conserve? So the flow of this talk is going to be really brushing on three main chunks. So it's, first of all, I'm going to talk about how these really complicated systems are changing, and I'll discuss some sort of broad thinking as well as specific results in there. And then I'll present three vignettes. Some of those vignettes are bigger, some are shorter, about the sort of linked processes of climate resilience for estuaries, rivers, and then headwaters where glaciers touch rivers. And then I'll end with just some random thoughts about paths forward. First of all, I just want to introduce this topic of rapid change in complex systems. The reality is that these ecosystems, they're complex, and this is something that's not shocking. We know this, but I think sometimes we forget to really embrace that complexity. And if we think about how a wetland like this that salmon might be migrating through, we need to think about processes of hydrology. We need to think about how the water flows, how the habitat's created, how the habitat is eroded, by these floods, and then also how the vegetation shapes it, and then how salmon then sort of filter all this through their population life cycles. There's a lot going on. So, I think one of the ideas that's really resonated with me that was advanced a lot by my former PhD advisor, Daniel Schindler at University of Washington, as many others, is this idea of sort of shifting habitat mosaics and how these local changes, even if they're not predictable, can provide sort of dynamic stability to these complex systems. So if we envision this sort of cartoon here, where we have a archetypical salmon watershed, we might have these different sort of layers or filters, where we have a physical landscape. That's the sort of mountains and the actual valley forms. So the climate is sort of filtered through that at the first level. That then manifests itself in different sort of chemistries. Maybe it's like the pH or the amount of dissolved organic carbon in the landscape. Then there's a sort of ecological filter, things like alder providing nitrogen to the system, helping shape these ecosystems. And the last part is salmon biodiversity, the different genes, the different local adaptations that have evolved to this diverse habitats. And then the manifestation of all that complexity, all that filtering, all those interactions is then the ups and downs of salmon populations, where in one year a salmon population might be doing better, but the adjacent one might be struggling. But through this complexity, there can be a diverse portfolio that provides stability through times of change. So this is sort of a general idea that I think really resonates and is important to think about looking towards the future as well. And I think one of the things that my team has been doing is also trying to ask the salmon, well, how are your systems changing? And one of the important response variables that we might think about is the timing of their life history events, such as the timing of that mass migration of juvenile salmon from fresh waters where they're born and rear out to the ocean. And the timing of that probably matters a lot, because if they match up with their food resources in the ocean, their populations will probably survive the ocean better. And if they mismatch, then they'll struggle. And so a former PhD student, Dr. Sam Wilson, as part of her thesis, compiled data on the timing of smolt outmigration up and down the coast from California to Alaska, an insane amount of work going through gray reports, looking for these time series of when do these young salmon go out to the ocean, and how has that timing changed over time? Is it getting earlier or is it getting later? Based on the literature, we might predict that it's getting earlier. Things are warming up faster, spring is earlier. Maybe salmon are just keeping pace with that. Maybe we're predicting, okay, yep, salmon are just marching along with climate change. What the data suggests is much more complicated, much more nuanced. If we look, in general, for some of the species, they are getting earlier, but most of them, we can't predict whether they're getting earlier or later. So here are several dozen populations of coho salmon from Alaska down south. And what we see is their change in the peak day of year, whether they're getting earlier or later. And what we see is crazy variation, right? We see some of them are getting earlier and some of them are getting later. And no matter what variables we threw at this, we couldn't predict it. Latitude didn't work, elevation didn't work, nothing was predicting this. So it seems like it is probably some manifestation of local adaptation, that genetics layer of the sort of local climate filtering provided by the watershed. And the data can't keep up with this. So on the one hand, this is hard as a scientist to be like, oh, we can't predict it. But at the same time, that unpredictability is important pieces of information too. And by understanding the things that we can predict and not, that does allow us to think about, all right, let's preserve the whole, let's keep these different pieces because we don't know how they're going to respond into the future. This is really pointing us towards this sort of amazing biodiversity of salmon systems. So we think about where salmon spawn, and it could be a coastal stream like shown here, this emerald green rainforest, or it could be an alpine lake, or it could be an interior desert. All these habitats salmon can thrive in. And they have different life histories that allow them to take advantage of these different, different flow cycles and temperatures and different genes that are coded for those things. And so we have all these different components of salmon biodiversity across the landscape, and as the climate changes, they're going to respond differently. As another project looking at this, one of my grad students was thinking about the timing of adult migration of Chinook salmon, the largest of the Pacific salmon in North America. So she compiled information on their migration upstream and the timing of that across their range to try to get a sense for how that varies and what the implications of that for oncoming climate change. So again, insane amounts of hard, gnarly work where you're going through records, gray reports, compiling it, trying to ground truth it, and these are those data. So what we have is populations, the average run timing, and their spread, with each population being a different point with error bars across their range from the Central Valley of California, shown down here in fuchsia, pink, something like that, all the way up to the north to a salmon-colored Alaska. And the map of those points corresponds to the right. This is work by Anna Potapova. So what we see is across these hundreds of populations, across these different locally adapted salmon populations, this insane variation in when they migrate upstream. In California, we have some migrating early in the spring, maybe like February or something like that, but then also some migrating upstream in October. As we go north, that starts to coalesce and join, such that in the Fraser, for example, most of it's happening during the summer. And then when you get farther north, all that adult migration is happening during July, pretty much. So what we think is happening is that this is, of course, a signal of the climate conditions that they've experienced in the past. And so presumably in California, it's too hot to migrate upstream during the summer. So populations have either adapted to migrate upstream earlier before it gets too hot and then hang out in those cold headwaters, or migrate upstream later in the fall after the hot summer to get upstream there. But then as you move up north, you have that sort of available temperature regime contracting. Now, it's interesting to think about this sort of zipper of climate change, right? What we might predict is that as climate change happens, those life histories should become unzipped. And it's, we're right at that zipper. We're right at the pinchy point of that zipper where we should think that, all right, our populations should be diverging. If we think about what the implications of this might be for climate change, to me, this points to the fact that, well, salmon have really solved a lot of this already over millennia. If we look to the south, they've dealt with super hot water. The question is, can they keep up with it? And can we give them sort of time and space for this adaptation? I think the short answer is we don't quite know if they can keep up with the projected climate change, but it's actually, if you sort of do the back of the envelope calculations, it's not that dark of a story. It seems quite possible that the projected need to change is within the realm of observed change in populations, if we can keep all the pieces. So the way I've been sort of thinking about diversity and resilience for salmon, and then the broad picture is really thinking about these as puzzle pieces. All these different genetics, all these different life histories, they're all sort of puzzle pieces to a future. And I sort of think we don't really know what that future is. We don't really know what those puzzle pieces are, but by keeping them all, I think it can maximize the resilience and the ability of the system to keep pace with climate change. I'm going to transition now to some vignettes about specific systems. And we're going to work from estuaries up. And if we revisit this idea that we have these sort of dual pressures on salmon systems, and these dual pressures are the sort of direct impacts on salmon habitats, but then also the sort of climate change impacts, and how these dual pressures pose both challenges and opportunities. So this section focuses on the estuary part. This is the sort of place where salmon migrate from the freshwater to the ocean. They might rear there for weeks to upwards of several months. And it seems like a really critical point in their life cycle. They might grow up there, and that can boost their survival later on. So we've been working in a lot of different estuaries. It's fun field work. This is a picture of what it might look like. There's volume 2, I guess. But it's of me not trying to not get dragged into the ocean as we're sort of setting a seine. And we do this, lots of different habitats, trying to figure out where the salmon are, what species are where, how big they are, what they're eating, and using that as a basis for much of our work. It's fun in part because we don't always know what we're going to catch. Sometimes we might catch something like this, a salmon shark. When you're thinking you're going to expect, 80 millimeter long coho salmon, and you pull in this guy, it's a little bit exciting. One of the projects I want to highlight is up on the Central Coast in partnership with the Heiltsuk First Nation, where we've been working on the Quay River to quantify the salmon life cycle. And so as part of this, over many years, we've been tagging salmon smolts with little pit tags, and then figuring out, when they go out, how many survive. And what we've found out, and this is work by Alex Sawyer and her masters, is that these young coho salmon do exhibit extensive estuary rearing, upwards of 40 days. And they also grow really fast, probably about 10 times faster than they grow in fresh water. And this leads to about a 9% increase in their length prior to ocean entry. And when I heard this, frankly, I was underwhelmed. I was like, 9%. I was hoping for 50%, but 9%, I'll take it. It's what it is. But then I started to think about it a little bit more, and I realized that 9% is about the difference between myself and an NBA basketball player. And if we assume there's no difference in athletic ability or skill or training, then that is actually kind of a big deal. So maybe salmon are allowed to become the LeBron Jameses because of estuary growth or something like that. But anyway, it's cool because if you crunch the numbers, that's actually true. So that 10% increase in growth leads to a 40% increase in marine survival, all things being equal. It helps them climb that size selective curve in the ocean where the biggest fish survive due to that estuary growth. So 10% might not sound like much, but actually we estimate has large population level consequences. So this is all setting the stage for this observation. Okay, these are critical habitats, and what happens here, whether pressured by climate change or industrial activity, is important. And estuaries are places where there is high pressure. They're one of the most pressured ecosystems in the world, arguably due to the their suitability for ports and developments and other human infrastructure. And I thought I'd take a quick moment and talk about sort of a research arc from several years ago up in the Skeena in partnership with Loch Hallam's and Skeena Fisheries Commission and others. And we are working up in the Skeena estuary in this area here, Flora Bank, which is, you can see that at low tide, it's the largest eelgrass habitat right where the Skeena meets the ocean. And this also was, after we started work, the proposed location for a massive fossil fuel terminal, LNG terminal associated with Petronas, the Pacific Northwest LNG terminal. So our team studied this for years, and it was just amazing to be out in the water, working shoulder to shoulder with these guys, and just really inspiring work. And what we're trying to do is just trying to understand, okay, what are the risks of this massive project that's proposed for this area? What we discovered is that this specific habitat was disproportionately important for salmon. We estimated that there's 25 times more abundant salmon, more high density salmon in this region for sockeye salmon than other regions that are sort of comparable, even places that have eelgrass. And these papers got published that sort of asserted this. And we also were trying to understand, well, who does this actually support? And one of the things this is really important about is that the environmental decision-making process really narrowed the scope for who was sort of thought about. One can imagine that this company didn't want to consult with all the nations in the watershed. They wanted to consult with the local nations. And so we're interested in understanding, well, which salmon and whose salmon are supported by this habitat. So we used genetics. We collected tiny little fin clips of the fish, and those genetics allowed us to ask those fish, where are you from? Maybe from the Babine River, 300 kilometers upstream, or from Kitwanga, 100 kilometers upstream. And what we discovered, not surprisingly, is that fish at the base of this watershed that's the size of Switzerland, supported populations from throughout it. And this isn't surprising, perhaps. We know that salmon swim downstream. We know that there's high levels of local adaptation. But what it does indicate is that what happens at this estuary, at the base of this river, could affect, as far as salmon swim, could affect the whole. And so this was collaboratively published in Science with different First Nations from throughout the watershed, where we discovered over 50 populations of salmon from 10 First Nations territories. And these data, of course, were shared with those First Nations upriver to help them be a part of this conversation about how this decision should unfold. And in the end, the project was canceled with sort of a suite of lawsuits sort of delivered at their desks. And I will say that it was an incredible honor to be a part of this process. And after that decision was rendered, being a part of this totem pole raising ceremony where people from throughout the watershed came together and held onto these ropes and lifted the sort of symbol of protection into the sky, really resonated with me about thinking about what are the scales of connection in these ecosystems? How can one thing in this one area affect the whole? And how can people come together at those scales to try to inform decision-making? Okay, so that's one suite of pressures, is these sort of large industrial projects. And then at the same time, climate change is happening, of course, as well. And so we have projected sea level rises at 2100, or 65 centimeters increase projected. But then if the ice sheets goes, then it's going to be 1.3 meters increase. So large scale projections in sea level rise, and this could inundate those estuaries. The thinking is that those estuaries might be able to adapt and sort of move upstream if they're not sort of blocked by infrastructure. So here we have a picture of a Vancouver Island estuary, sort of with arrows of where that estuary might be able to migrate with climate change, and then where it is blocked by infrastructure. And here we have some dikes that sort of block that migration. So there's a large project called the Estuary Resilience Project that we're a part of that's looking to understand this type of question and then use that to inform restoration. How can we restore these habitats? How can we restore these estuaries to enable resilience? All right, moving on. So that's the sort of estuary vignette. Another vignette that's going to be shorter is the river vignette. And so in these rivers that salmon call home, there's multiple stressors. They're working watersheds. A lot happens here. So in, for example, one watershed in the interior where there's endangered salmon, this is just a time lapse of the logging that's happening in this system. So a lot of pressure on these systems. And the science, our team is contributing to this, but here's some other references, is that this logging will have impacts on these watersheds. It'll warm the water temperatures and it'll change the flow regimes. The water will get warmer, for example, between 2 to 6 degrees, depending on the study and the place, and low summer flows will drop around 25%. This is the same predicted impacts of climate change. 2 to 6 degrees, depending on your scenario and your place, that's 100 to 200 years of climate change. So with logging, you're either exacerbating the climate impacts, or if you do it better, you could actually ramp back. You could mitigate those. So to put those into context, we've done some work in the interior. We're relating the amount of water in the river to salmon. This is showing that the summer flows related to their productivity, their population. If it's below 1, the population is dropping. If it's above, then they're above replacement. Not surprisingly, salmon need water. So when there's more water during the summer, they do better. But these levels were way more than was thought, and it can help then inform water management such that we can make hard decisions about how much water to leave in the river. So we can envision that water withdrawals, forestry, and climate change could be pushing us down this line. On the other hand, if we do things better, then we could be pushing up this line. And it's a really exciting place to work. There's ongoing government-to-government negotiations and land use planning that is trying to tackle these hard questions about how do we want to steward these watersheds into this future being led by indigenous groups. So that little vignette, again, a short little sample of how these systems have these dual pressures, and that presents challenges and opportunities. The last little vignette I want to show is about glacial retreat. We see these photos a lot, right? Where there's this crazy transformation happening, this incredible loss of glaciers, the ice melting and opening up habitat. And this is a global issue. Millions of people are going to be challenged by food security in Asia in particular with glacial loss. In BC, they're projecting that between 60 and 100% of our glaciers are going to be gone by 2100, depending on our action on climate change. The loss of these glaciers is going to pose downstream challenges. A really nice study was done in Southeast Alaska, and they found that during a massive heat and drought, that if those little catchments had more glaciers, they're less likely to have these pre-spawn events. And systems that had some remaining glaciers had those nice ice cubes on top of those watersheds, keeping them cool during the summer. So the loss of glaciers will increase climate vulnerability. At the same time, if those glaciers are in river valleys, glacier retreat will create new habitat for salmon. And salmon are finding these new habitats and they are thriving. So work by Sandy Milner, for example, there's a stream that was created in 1970 by glacier retreat. And then several decades later, tens of thousands of salmon were spawning in it. So PhD student Kara Pittman mapped this out actually across the range of salmon and glaciers and asked where and when new salmon habitat will be created by glacier retreat. She estimates that over 6,000 kilometers will be created with hotspots in the northern transboundary regions and southern Alaska. We've been working in some of these locations in collaboration. My team working with Tuck River Tlingit and Flathead Lake Biostation. And it's pretty amazing to be in these new rivers and you pull a seine and you catch salmon. They're finding it, it's happening. And so it's really just amazing to see. And also to say it's really, I feel pretty blessed to work in these places. This is a picture I took a couple years ago of a grizzly bear on a counting weir with a Chinook in front of it, and just pretty inspiring to be close to these animals. And then it dove on it. I never thought I'd just be like soaked by a belly flopping grizzly bear. That'll wake you up in the morning for sure. But anyway, these systems are changing really fast. So this is one of the places where we work, and we have, a picture that was taken by our key collaborator, Mark, in 2007, and you don't see a lake. And then in 2019, there's a big lake. This lake was created over the last several decades. And it's you get out on the ground, well, actually on the water, and this didn't exist when I was born. And now I'm in a lake that's intimidating big, and it's going to be future salmon habitat. At the same time, it's not just salmon that are looking to these landscapes for the future. As the glaciers are retreating, mining companies are looking to these ice edges for the next big claim. So here's a quote from them. In 8 years of glacier retreat, at the rate it's been going, there could be an ore body sticking right out of the ground that nobody's ever seen before. So mining companies are actually staking claims on glaciers preemptively to get the rights to the minerals before the ice even melts. And this Also, because of commodity prices, is associated with a modern day gold rush for this region, where there's a hotspot of habitat creation for salmon, as well as a hotspot for mining. And mining does, pose serious risks and harm to aquatic ecosystems if done improperly. So this really, I think, speaks to how climate is creating these crossroads. How are these systems headed? Which direction are they going to go? And I think there's some really inspiring examples of leadership in looking to the future to steward these systems. Gitniao First Nation, for example, declared a new Indigenous protected conservation area as they observed salmon colonizing new habitat, and they set that off limits for mining development that was also hungering for those systems. So I think across these vignettes, there's a sort of coherent similarity, where these dual pressures of climate change and our own actions are creating challenges. We're magnifying, we're exacerbating the risks, we're taking options off the table, we're pushing systems farther towards bad places. At the same time, with those challenges, I think there's real opportunities. What it means is that local management matters. What it means is that, yes, we need to take action on climate change, and yes, what we do on these landscapes will influence their resilience. So I hope across the arc of this talk, what I've done is just discussed and showcased a little bit of our work, talking about how these systems might be responding to change. We're talking about how resilience can be fostered or lost by our actions on the ground, and just end with some paths forward. I just want to echo this idea that I think keeping these options and really sort of doubling down on conservation in this era of change is of critical importance. And I added the sort of human dimension to this too. I think its puzzle pieces are of habitat, of biodiversity, but they're also of socio-ecological systems, of different management and governance styles. All these are important pieces towards an uncertain future. I also think we're at crossroads, and not just one crossroads. I think there's thousands of these little crossroads, these decisions that will take us towards or away from resilience. I think it's really important to have this climate lens. How are we managing these systems given they're changing? And all this, I think, speaks to this need for collaborative and forward-looking science, and then forward-looking action. Thank you. I think it's a huge, interesting question, and that is, how do we maintain our close connections to these systems while they change? And that's not really a question for science, I think, but I think it's a really a question for society as a whole. And I guess I'll say that personally, I think we need to embrace change and find the sort of beauty and connection even as our systems change. But it's tricky that we don't have a easy target anymore. I don't think we can sort of always be restoring to the past, because the past isn't valid for some places. So I think that's a great point. And I think local rights holders always have sort of primacy. Yeah. Great. Yeah, so there's two questions. The first question was, as those fish grow in estuaries, that 10% increase or 9% increase in length, what's that relative to? And the second question is, what are the sort of broad prospects for estuary conservation and restoration? So with regards to that 10% or 9%, that is relative to if they had just blown right through the estuary. If that estuary had been sort of taken off the map or totally channelized and they'd been dumped straight out to the ocean. I will say that the growth rates in freshwaters are so much lower that if they had stayed in freshwaters for that amount of time, it probably wouldn't be 9%, it would be 8% or something like that, or maybe 7%. And I think, yeah, so I think that's sort of the short answer for that question. It's a good question. And the second is sort of, what are the prospects for estuary restoration? The exciting thing is, I think there's a lot of action actually towards this. And so there's a lot of movement. Nature Trust BC, in collaboration with different partners, are doing great work on large scale dike removal, large scale opening of connectivity. Dave Scott's doing great work with others in the Fraser River estuary. And I think the sort of removing barriers, it works. You think about if salmon actually benefit, and yep, they always find new habitat. And so there is some scope for taking these systems towards a better place. there are always pressures too. And I think sometimes the sort of value of the land is a pretty big deal. So it's not all bright, but there are sort of exciting things happening. So the question was about whether Chinook salmon are changing their phenology and their outmigration similar to coho salmon. The short answer is yes. It's still unpredictable. So there's also a lot less data. There's fewer sort of populations of Chinook that are monitored long term. So Chinook were also unpredictable. The two species that were more predictable were pink or chum salmon. Those seem like they're generally getting earlier in terms of how they're migrating out. I think, it kind of makes sense that chum and pink are more predictable because they don't rear in fresh water, and so they're sort of emerge and go, whereas Chinook and coho are probably cued by a combination of temperature and sunlight and flow regimes and size and those types of things. So it kind of makes sense that those stream rearing salmon do have more variable responses. And I think your general sort of couching of the Chinook challenge is well said. Chinook, as you know, are not doing very well throughout their range. And it seems like it's a variety of pressures from marine mammal predation by pinnipeds to mixed stock fishing to overall climate change and habitat destruction. So I think it's a multiple stressor challenge, and definitely orcas are on the end of that.
Thank you, Sydney and John, for the talk. Really appreciate hearing about all the different facets of the work you have going on in the group. I'm curious about your work on the Skeena and in line with LNG, just thinking about how in science and the history of Western science in our institutions, there's such emphasis on not being, advocates or engaging politically. And I'm just wondering if you'd have advice for those in the audience around how you handled yourself in that space of like advocacy along with science, and whether you think they belong together. Thank you.
I guess I'll say that it was really challenging and scary. My approach in general is that I try to always be science-based and never lose that. And I also, if I'm entering that arena, to enter it hard and do good, impactful work. And then and so I sort of like stick my neck out and go hard, and then I go back to my safe place after I sort of get scared. And it was scary. I'll say that I'd give talks in industry. There would always be industry representatives there. I'd had nightmares about people coming to my home and killing my family and I. This is a surprised response by myself. So I guess I'll just highlight that it's not easy. And I think that I also am super proud of that work. So I think, trying to not go past the science is always a good thing for my own approach. And then also just really trying to be an impactful science communicator I think it's really important too. And so I think that's how I've tried to navigate it. And I'll say that it did, it was hard and it was controversial and not everybody was happy. And, there was a change in leadership and we were told to leave and then come back and then leave again. And so it wasn't a smooth road. But I'm proud of it.